Okay, so the whole idea of Inventor is to be able to model and design something that is in your head, put it on the computer, and then create drawing files for it. Okay, so any physical object you can create in here. You can specify materials. Those materials have properties. The properties can be used to analyze whatever model you're making. Okay, so when you open it up, you want to go to New. Within Inventor, you've got parts, which are here. Assemblies, so standard parts, standard assembly, and then standard IDW. Okay. Parts. If you think about any object, for example, pencil. Okay. Pencil. You've got an eraser. You've got the metal ring around it. You've got the wood of the pencil, and then you've got the lead inside the pencil. So a pencil itself would have, if you count the parts, lead, wood, metal ring, eraser, 4 different parts. Okay, to a pencil. So you'd have to make 4 separate parts, so there'd be 4 separate part files. Okay, you want to create a folder and save everything in that folder that deals with that project. Okay, then you have assembly, where you put the eraser, the metal ring, the wood, and the lead all together. Okay, once you do that, you've got a model that you can analyze. You can go through stress tests. You can put loads on it and see what happens to it. That's good for your design principles, but then how are you going to actually communicate your design with other people? You've got to use this standard IDW. Okay, that's the drawing template where you create this drawing file, then you can send it to the engineer to be able to manufacture your parts. Okay, so you'd make a drawing file for each individual part. So you'd have an IDW or drawing file for the pencil. You'd have, or the lead, the wood, the metal ring, and the eraser. You'd have 4 separate drawing files, and then you'd have a drawing file of the assembly. Okay, so we're going to start with the part. Double click on that, should open up a window here. So when you're working with that, you're drawing in a 3D environment where you have unlimited, basically unlimited space. You could design a football stadium, or you could design a small blade, a surgical tool. Okay, so you're in a 3D environment. This is a 3D environment here. Here's how you move around. If you hit the home button, you've got this cube, and then everything in here is just a environment that you can design stuff in. So if you drop down this is the browser over here. You go through this folder. You've got different planes that are existing. Okay, so you got the front, top, right side plane, which you'd have used when you did drawing files in ID. Okay, so we're going to select this XY plane. That's like the front plane, and then I'm going to click on Sketch. Okay, so we're creating a 2D sketch on this plane. Okay, you need to have it fully defined, so you always want to start off with an existing point, and the origin is always an existing point. So I'm going to get a line tool, and you see how it turns green there. Okay, that's snapping to that existing point. Okay, so I click to start there off my origin, and then I'm just going to make shape of the truss. Okay, this is a line. Okay, I can't do anything with a line because that's like no. You got to have thickness to it. Okay, so you can't do anything with a line. You got to have a closed-in feature. Okay, so I'm going to go ahead and start putting dimensions on this because I want my lines to be defined. So I'm going to set a dimension here. I'm going to say that's my minimum is 10, my maximum is 11 for this truss. I'm going to put 10 there. Okay, this is going to be the center of my material. Okay, and then I'm going to get another dimension from here to there. I'm going to set that at the height max was 4, so I'm going to go 3.5. Okay, now it's not in the center. Some ways you can do dimensions as well. If I click here and there again, move it up. Okay, I've got the width dimension, so I can set that there. And then I want it to be half of this, so I'm going to click on this dimension and then do divided by 2. Okay, so you can do equations in here. If you don't know what the fraction is, you can just put in the fraction, it'll do it for you. Okay, so it's this dimension, this bottom dimension here, divided by 2. And then enter. So now that's always going to be in the center of the part. So if I want this to go to 10.5, okay, yeah. Okay, that's going to adjust this dimension too, because it's in relationship to that width dimension. Okay, so I still need thickness, so you can do it a couple ways. This offset tool, okay, the more complex you get, the more you'll have to do it. So you can just get another line in here if you wanted to, and put your lines in there, and then you dimension it. Well, how far from here to here? Okay, it's giving me an angle, so that means they're not the same angle. So I got to go to parallel. These are constraints. So I want parallel constraint. I want this parallel to that. I want this line parallel to that line, and I want this line parallel to that line. Okay, it pops up because it's already been constrained to that. Okay, so I can just hit cancel there. So now if I get the dimension tool, click on those two, now it's going to give me a dimension between those two. And my board, the max I can make is 0.19. Okay, so 0.19, I'll do the max on that. Okay, so there's my thickness. So I'm still in the dimension tool, so I can click here and here. And instead of putting 0.19 again, I can just click on this dimension and hit enter. This dimension, click on this dimension again. Okay, so if I wanted to say maybe my redesign, I change this dimension. Okay, so let's say I wanted lower weight or cost, so I put 0.15. Okay, it changes those as well. Okay, so this is my base truss. In the instructions it says I need a joint. Okay, so to draw my joint, I'm just going to click on this point here, and the diameter is 0.75, so I put that in. Okay, there's a joint. Go down here, 0.75. Okay, let's see if this one gets it. Okay, so whether you want to put it here or actually, yeah, we should definitely do this one instead of that one because that's not connecting the two members. So I just delete that, go back in here, and I want the joint to be getting both members. Okay, so if you don't dimension it in when you're making the circle, you can get the dimension tool and dimension it 0.75. Okay, so there's my truss. Okay, I use lines, I use circles, okay, I use constraints and dimensions. You want it fully defined, okay, so that you're specifying exact measurements. Okay, so once you're done with the sketch, it's what you want for the truss, hit finish sketch, okay, and then you're going to extrude it. So extrude, you got to go in here, okay, this is the drop-down window profile, okay, I want to extrude any closed-in features. So I got the truss, but it doesn't have these two joints yet, so I want to go in here and make sure I select everything I want. If I select something I didn't want, okay, now you can hold Control and click it again to deselect it. Okay, then you need to set how far it's going to be extruded. So this is the actual thickness of my board is 0.19. Okay, so that's the actual thickness of the luan that we're going to be using. Okay, there's my truss. Okay, I've got this. Now I need to, so this is my part file. I want to save it. Okay, go to create a folder. Okay, so I've got this in the POE folder. I'm going to call this Truss Design 1. Maybe simple triangle. Okay, so save that. Then I'm going to go to New. Okay, and I want a drawing of this. You have to do this for your project. So I'm going to hit Create there. Okay, so it's getting this drawing file up. This is like your piece of paper that you could print off and send to the engineer to make your truss. Okay, so right now it's an ANSI large if you look over here in the browser. Okay, and I want to change that, so I'm going to right click on the sheet 1 and go to edit sheet, and I want this to be an 8.5 by 11 sheet of paper, so that's a size A. Okay, so we switch this to size A. That's height of 8.5, width of 11. Okay, and my truss can fit in there, full size, right? So I could set that and check and see if the laser cut it exactly out or not. Okay, so I've got this piece of paper. I set the size of the paper, and now I'm going to hit base. Okay, now I need to find the truss. So there's the file. If it doesn't pop up, you go in and find your file. Got it selected. So here's the scale here. I'm going to go 1 to 1. Okay, it was 10.5, so this border here is cutting it off a little bit, but I want it to be as a full-size model. Okay, so set my truss in there. Okay, so again, scale. I can change shading type, how it's put in there. And ours are pretty simple, so you can just stick with that first style. So hit OK there. There's my truss. Okay, so some of the requirements were to put dimensions on it. So you need your overall dimensions. So from furthest point to furthest point. Okay, it sets a dimension. Hit OK there. Get dimension height. So I'm going to go from here to up there. Okay, so I initially set it at set it right there. Okay, so 3.5 was what I set the points at, but now it's 3.92. So keep that in mind. With the overall size needs to be within 4 and within 11. Okay, so there's my heights. Additionally, I need to add text. I need to add the material. Okay. Luan 0.19 inches thick. Okay, so we've got that. Now I need to find my material properties. What's the mass of my material? So I go back to the part. I right click on the truss in the browser, go to iProperties. Okay, so I'm not doing the calculations on the size of this. I just go to the physical tab, and then I'm going to specify material as wood birch. Okay, if it didn't update, you can hit update here. There's my density, there's my mass, there's my area and volume. Okay, so for this, I'm going to copy the mass. Okay, go in here. I'll just start a new text document. Text box, okay, and then mass, and there's my mass in there. Okay, I have that note. Once you actually test and break your truss, you're going to put what the weight was that it held up. Okay, so you'll get that. So we've got this, we've got the drawing. Okay, now we need to be able to make this part. Okay, so once you have the part file, you got to actually get a DXF and cut on laser. Okay, so you click on Start Sketch again, click on this front face, and then hit this Project Geometry button. Okay, click Project Geometry, move over the top. It turns yellow lines on the outside of the material, on the outside of your truss. Okay, so the laser is actually going to cut where those yellow lines are. So that's what we want to finish sketch. To get this file to cut on laser, you right click, export sketch as, and then select DXF. Name it. That's what you'll save on the flash drive and print out. So, forgot we need to add a little notch for where the force tester holds onto this truss. So I'm going to add this in, and then I'm going to show you how to do stress analysis. So I click on Create Sketch, click on this front surface here, and Going to get a rectangle. I'll just do this center point rectangle, and so I'll snap here, go up, get dimension, and I'll go 0.3 and 0.3. Okay, I'm going to make this deeper. The width of that piece is 0.25, so I want it to be able to set down in there, so I'm going to make this a little bit higher. I'll go 0.5 there, so the piece for the load test will set right down in this part of the truss. So I'm going to, shoot, it's not fully defined, so I'd go back in and put a vertical constraint on it. I'm going to click the center point here and the center point there. Now it's fully defined. Finish sketch, extrude, and I want to select inside that component, but it's going to add material. We want to cut material. So I'm going to cut all the way through, hit finish sketch, and there's the notch. So I'm going to go back in, delete the laser, start a new sketch, click on it, go project geometry in, select that surface. Now I got my lines for the laser. So I got to right click on it, export sketch as, DXF, name it, and you're good. So now if you want to simulate it, you can actually put loads on it, test it. So you go to the stress analysis, and you can add different types of forces on there and see where the how the forces impact your truss. So in order to do that, you click on Create Study. We're doing a static analysis, hit OK, and now you place a pin on one side of the truss, right there, hit Apply. You get a frictionless constraint on the other side, right there, hit Apply, and once you have that, we want to get a load placed in there. So I get a force, I click right here, that's where the force is going to be applied with the tester. I'm going to put 100 pounds of force in there, hit Apply, and that's it. So you got a pin on this side, you've got a frictionless on that side, and then you add a force right there. You can set whatever force you want, and then you hit simulate, hit OK, hit run, and now this is going to create analysis of your truss.
BAM!
Go to safety factor, and you want it to be over 1. So right here, that's the most stress on any part of this member, 1.07. So that works. If you want to animate it, you can click there, play, and it gives an exaggerated motion of what's happening.
Woo!
So do that to test it out before you cut it out on the laser.